Hello Math 1 students. Today is going to be a bit of review in preparation for our next unit. We're going to review solving equations and graphing lines. You should by now have this solving equations and graphing review worksheet on your desk. If you do not, pause the video until everybody has it on their desk. We're just going to dive right in. We're going to solve these equations. When we're solving, we're trying to isolate the variable, which means one of the best ways to do that is to undo all of the things that have already happened to it. So in problem number 1, I'm looking at my variable, which is a, and I'm looking at all of the things that happened to it. And I see that that 10 is really close to it, so I know that we divided by 10 first. And then after I divided by 10, that is when I added 6, which means as I'm trying to undo each of these things, my first step as I'm solving this equation is going to undo the last thing that happened to it. So I begin by adding 6 to each side. Whatever I do to one side, I have to do to the other side in preparation of getting that variable all by itself. So that negative 6 plus 6, that canceled out. That's the reason why we did that. And that leaves me on the left-hand side with negative 7 plus 6 simplifies to negative 1, and it is equal to a divided by 10. Our a still isn't alone, but we just said a is divided by 10, and we undo division by doing its inverse, multiplying by 10. Now whatever I do to one side, I have to do to the other side. So I am choosing to multiply this right-hand side by 10 because that is what will undo division. So that very simply cancels out. The left-hand side we simplify. 10 times a negative 1 is negative 10, and it is equal to a, and since a is now all by itself, we have isolated the variable, and I know that a is equal to a negative 10. Right, so these first couple problems are nothing new. It's all stuff that we have seen before. It's just practice to get us it nice and fresh in our minds for what we have coming up next. Number 2, 4 is equal to r plus 6 divided by a negative 3. So when I'm looking to see what happened to it first, I'm looking to see what's closest. And this time I see that the 6 is even closer than that negative 3 is. It's so close that they squished it right up there on top. That's how I know that that is what happened first. That means after I added 6, that's when I divided by a negative 3. So just like your shoes and your socks, we did that divide by a negative 3 last, like we put our shoes on last, but it's the first thing that we're going to be taking off. And whatever I do to one side, I am going to do to the other side. Now, just like I saw before, multiplication is what will undo that division. That's how I know that that just cancels out. So all I have to do is simplify the left-hand side. Negative 3 times 4 simplifies to negative 12, and it is equal to, since that negative 3 canceled out, it's just equal to r plus 6. Our next step, we're looking to get that variable by itself, so I'm going to subtract 6 from each side. Simplify the left-hand side. Negative 12 minus 6 is negative 18. Negative 6 subtracted from that positive 6 ends up canceling out, leaving me with just r. My variable is alone, so I have finished solving that equation. Let's move on to the next ones. We're going to start with number 3. Number 3, again, same idea. We're just trying to undo all of those things that happened. So when I'm looking to see what happened to the variable, again, I'm asking myself what happened first. What's the closest thing to it? And I see that k, and the thing closest to that k is a 10. We have multiplied by 10. So that's the first thing. That's like putting on our sock first, which means I have to save that for later. After I put on my sock, I put on my shoe. So after I put on, or multiplied by 10, that's when I subtracted 6. So I go ahead and undo that by adding 6 to each side. Simplify. 94 plus 6 is equal to 100. This negative 6 plus 6, that ends up canceling out, leaving me with just 10k. Keep on getting that variable by itself. 10k, that really means 10 times k, and I undo multiplication with division. Whatever I do to one side, I do to the other, leaving me with 100 divided by 10 is equal to 10. 10 divided by 10 cancels out. That's the reason why I chose to do that division, to undo that multiplication. And I have my variable all by itself, k is equal to 10. Last problem here. Now on number 4, you may be tempted to distribute, and It is definitely going to work. But I want to show you how that same sort of idea of what I've been doing is still going to work this time. Again, I'm looking to see where the variable is, looking to see what's closest. That would be that we added 2, which means I'm going to save that for the end. If that's what we do first, just like your sock, it's what you undo last, right? So after I look at that a plus 2, then I can see that all of that has been multiplied by a negative 2, which means I'm going to go ahead and undo that multiplication right here in the very beginning. Some of you might prefer to distribute, and that's okay, but I still want you to understand that negative 2 divided by negative 2 is going to cancel that out, so I don't need to worry about distributing here. Now when I simplify, all I'm left with is just 2 plus a is equal to 22 divided by a negative 2 is negative 11. Still working to get that variable all by itself, which means my next step here is I'm going to be, oops, I see a plus 2, so I'm going to undo that addition by subtracting 2 from each side. That cancels out that 2, leaving me with a equals negative 11 minus 2 simplifies to a negative 13, and our variable is by itself. Right, so this is nothing new. We've seen lots of equations like these before. Here's where it's going to start getting a little bit different, okay? We're just going to begin, if you take a look at 5 and 6, and actually I think the rest of them that are on this, this front side of this paper, you're going to see that in every one of these problems we have the variable in multiple places. Now we can still solve this equation, but our goal is to first get all of those variables to one place. So when I'm looking at number 5, I'm going to look at just one side at a time. Let's just tackle one side at a time. And as I'm looking here at this left-hand side, I can see I've got the variable in 2 different places. So I want you to understand that since the variable is in 2 different places, we want them to be in one place. I'm going to rewrite this to be 8n plus 5n plus 5. I can do that because multiplication is commutative. I can do it in any order that I want. I think you all agree that 3 plus 2 is no different than 2 plus 3. Just like 3 plus 2 plus 1 is no different than 2 plus 3 plus 1. Right? I can change the order here, and it's not going to change how true it is. It's not going to change what it ends up being equal to. And that's all that I've done here when I rewrote this problem. I put my 2 n's closer together, and now I hope you can recognize that if you have 8n and 5n, you can combine those terms together. That's what we call combining like terms to get 13n. 13n plus 5 is equal to a negative 13 plus 7n. So we've simplified that left-hand side. We can't do anything else with it. Let's take a look at the right-hand side. Negative 13 and 7n. There's nothing I can do there. I can't simplify that side. And so now that each one of our sides is simplified as much as we can, now we're going to work on getting our variables to the same place. So again, I've got some n's over here on the right-hand side, 7 n's on the right-hand side. I have some n's over here on the left. That would be 13 n's over there on the left. So I want to try and get them to just one side. You can choose. You can take it any direction you want. I am going to take 7n from this side because when I subtract 7n from here, it does cancel that out. But whatever I do to one side, I've got to do to the other side. Now watch what happens. It is now gone from the right-hand side, and 13n minus 7n, that simplifies to 6n. We still have our plus 5, and it is all still equal to negative 13. And now this looks an awful lot like the other equations that we've seen. So you should know from this point all you need to do is work on getting that variable by itself. So I'm going to begin by subtracting 5 from each side. Whatever I do to one, I do to the other, so I'm just keeping this balanced. And I'm left with 6n is equal to a negative 18. Going to undo that multiplication that's happening there, so I'm going to divide each side by 6. Those 6's cancel out, leaving me with n equals a negative 18 divided by 6 is equal to a negative 3. Now again, most of that is not even very new. We have seen stuff like that before. So I want you to practice this with problem number 6. Not right this second. That is going to be something that you're going to practice on your own. I just want to show you a couple more kinds of answers that you're going to be seeing. So we're going to skip 6 for right now. It will be part of your homework. Let's take a look at 7, 8, 9, and 10. Those are the last ones that I'm going to be doing here in class. We're going to begin just the same way that we did before, where I'm going to start simplifying one side at a time. So when I'm looking here at this right-hand side, 3n plus 7 plus n minus 6, there's a lot going on there, and I can see I've got constants that I can combine, and I have n's that I can combine. So the first thing I'm going to do, and maybe you're okay to skip this little baby step, but I like rewriting it in order so that I have my like terms right next to each other. It helps me understand what it is that I'm doing as I'm simplifying and trying to combine them. Right, so I really didn't change anything, I just rewrote it in a different order. As I rewrote it, I kept the signs together, so that 6 that we're seeing right here is really a minus 6. So when I rewrote it, I continued writing minus 6. So I did keep those signs together. And now I can just combine those like terms, 3n and n, combine to give me 4n. 7 minus 6 simplifies to 1, and all of that is equal to 1 plus 7n. And just like we saw before when we got to this point, the left-hand side is as simplified as it can be. The right-hand side is as simplified as it can be. So now I want to start moving those variables to get to the same side. So I'm going to subtract the 7n from this side. That way it's gone. Whatever I do to one side, I'm going to do to the other side. That leaves me with 4n minus 7n is negative 3n plus 1 is equal to 1. Continuing to solve, I'm working on getting that n by itself, so I subtract 1 from each side, and I get negative 3n is equal to 0. We're still not done, but don't freak out. 0 is just a number. All I know is that I'm trying to get this n all by itself, and I know that the way I undo multiplication, because it's negative 3 times n, I'm going to undo that with division. And whatever I do to one side, I do to the other side. Negative 3 divided by negative 3 ends up canceling out. That means on this left-hand side, I'm left with just plain old n. And we're going to simplify the right-hand side. 0 divided by negative 3 is still 0. So my answer is n equals 0, and I'm not freaking out about that answer, n equals 0, because 0 is just a number. Let's take a look at 8. We're going to see something else that's kind of interesting, but I don't want you to get confused between what we saw in 7 and what we saw in 8. All right, and same as what I've seen before on number 8, we're going to look to try and simplify as much as we can. So I'm looking at that left-hand side, 5n plus 7 plus 1, and I can see some like terms that I can combine. So I'm going to do that first. 5n plus 7 plus 1, combine and simplify to just give me 8, is equal to 5n plus 8. And already, I'm hoping that maybe you see something interesting here. 5n plus 8 is equal to 5n plus 8. Let's keep on thinking about that, and let's keep on solving. Like I encouraged you to do before, we're trying to get the variable that's in two different places. I've got some variables here and some here. I want to get them to the same side. So I'm going to move this 5n over by subtracting 5n. 5n minus 5n, that is going to cancel out, but whatever I do to one side, I have to do to the other. And since I subtracted 5n from that right-hand side, I'm going to subtract it from the left-hand side here as well. Now let's simplify. 5n minus 5n, interesting, that also cancels out. That leaves me with just 0. So this part here, that simplifies to 0, but I do still have plus 8, so I need to make sure I bring that down. Bringing down that equal sign, this 5n minus 5n, remember that also simplified and canceled out to 0, but I do have this plus 8 that's still left over. So this really means I've got a positive 8, 0 plus 8, which we know is just 8, is equal to 0 plus 8, which we also know is equal to 8, and we're just left with this really weird equation that simply says 8 is equal to 8. Here's what you need to understand about this. This is a true statement. Is 8 equal to 8? Yeah, it is. It is very obviously true. And when you get something like that that is very obviously true, you have to interpret what this means. When it's obviously true, if this is important enough for me to write down, it's important enough for you to write down as well. So please include this in your notes. Something that is obviously true really means that there are infinitely many solutions. Or you might even say all real numbers. We could have discovered this way back here at the beginning. Once I made that first step and I simplified and I ended up with the equation 5n plus 8 is equal to 5n plus 8. Well, obviously that's true. It's basically saying that it's equal to itself, so of course that's going to be true. So as I'm taking these steps to solve it and as I'm undoing these things, I end up with something that is obviously true, like 8 equals 8. That does not mean your answer is n equals 8. Okay, instead it means infinitely many solutions. Here's what I want to do now. I'm going to erase all of this. I want you, we're going to pick a number and we're going to check our answer. So I'm going to pick the number 7. Because our answer was infinitely many solutions or all real numbers, I want to test it out and say, okay, what happens if n is 7? Is this going to be true? So I'm taking n of the value of 7, plugging it in for n anytime I see it. So I have 5, going back to the original equation here, 5 times n, which is 5 times 7, plus 7 plus 1. If this is true, I should be able to get 5 times n, which is 7 again, plus 8. Got to do some simplifying here, order of operations. So I'm simplifying this multiplication first. 35 plus 7 plus 1 should be equal to 35 plus 8. Let's keep on simplifying here. 35 plus 7 is 42, plus 1 more is 43, and 35 plus 8 is also 43. So I just picked a random number 7, plugged it in, and I got a true statement that 43 is equal to 43. So my answer does check. What I want you to do right now, I want you and your partner to each pick different numbers and plug them in. Okay, give it a try. Plug in different numbers, see if your solution checks out the same way that mine did when I plugged in 7. You're going to be choosing a different number than 7, and you're going to be choosing a different number than what your partner has chosen. Pause the video for about 60 seconds to 2 minutes while the students work on this. All right, and hopefully you've had a chance to go through this, check your answer, and you can see that it doesn't matter what we get, or what we choose to plug in. We all could have chosen something completely different and the result would have been the same. All real solutions, because we ended up with something that was obviously true. All right, and we're going to be seeing something pretty interesting here in problem number 9 as well. So let me show you what it looks like in problem number 9. Trying to simplify each side first, and I can see the left-hand side, negative 4 plus 8a, already simplified. Look at the right-hand side, 8a minus 2, already simplified, which means I can skip ahead to that point where I'm trying to move the variables to the same side. This time, when I'm trying to move the variables to the same side, I'm going to go ahead and subtract 8a from this side, because I know that's what it's going to take to make that go away, but whatever I do to one side, I've got to do to the other side. And just like we saw before, I am seeing that that's minus 8 from the right-hand side. When I subtract it from the left-hand side too, I see 8a minus 8a, and that's also going to cancel out and simplify. Okay, so what I'm really left with now is negative 4. Remember this 8a plus, or excuse me, 8a minus 8a, that simplifies to 0, equal to this 8a minus 8a, that simplifies to 0, minus 2, and we can simplify this. Negative 4 plus 0 really simplifies to negative 4, and 0 minus 2 really simplifies to negative 2. And here I'm left with an interesting situation, because I have something that says negative 4 is equal to negative 2. Again, this is one of those times where you need to interpret your answer. You need to understand that this means no solution. So this is something that is obviously false, Negative 4 is definitely not equal to negative 2. And when I see something that is obviously false, that's when I interpret it to mean there is no solution. All right, the solution isn't negative 4 or negative 2. The answer is no solution. And we get that whenever I see something that is obviously false. Okay, the rest of these are your own practice problems. Whatever you do not complete in class will become homework. So let's go ahead and pause the video for about 3 minutes. Give them 3 or 4 minutes to work on just a couple before we flip it on over to the back side. So go ahead and pause the video for 3 or 4 minutes. All right, and let's just summarize what we saw there on all of those solving equations. There are 3 different types of answers. We could end up with one solution or one number. This is the kind of equation that you've seen most often. It's going to be something like x equals 7. Okay? That would be your solution. Your solution is x equals 7. Sometimes, though, as you're solving, instead of seeing just one number, you will see an obviously true statement. An obviously true statement would be something like 7 equals 7. And when you see that, you need to interpret that to mean all real numbers, or you can say infinitely many solutions. All right, either one of those would be acceptable answers to me. And then you will also see sometimes where you don't have an obviously true, you have an obviously false statement. When you have an obviously false statement, you're looking for something that is actually unequal, like 7 equals 4. Okay, that is something that is obviously false. You need to interpret that. When you see that, you need to interpret that to mean no solution. There is not a single number that we could plug in that would make that equation true. So, understand what you're looking for when you're solving each of these equations, and let's go ahead and begin graphing. Just a quick review, every one of these equations is in slope-intercept form of a line. Here are the things that you need to be looking for. They are all in that form y equals mx plus b, where m represents our slope. Our slope is also our rise over our run. Okay, so we have y equals mx plus b, where this b represents our y-intercept. That is why they call this slope-intercept form, because there are 2 things that I can see when it's in this format, and that would be the slope and the y-intercept. That helps us for graphing because we begin here with our y-intercept, which is on the y-axis. And from there, we use our slope, our rise, and our run in order to find more points that are on that line. We have done this before. This is nothing new. So here's the things that I want you to be paying attention to. If I'm looking for this y equals mx plus b, the first thing I'm looking for is that y-intercept. Here is the y-intercept. It's not just 4. Pay attention to the sign. It is a negative 4. So I'm going to begin by placing a point right there on the y-axis at that number, negative 4. From there, I can use the slope, the rise over the run, 1/4. That represents our rise over our run. Where I'm going to start at that y-intercept. I'm going to rise 1, and I'm going to run 4. So up 1 and over 4. That gets me to my new point. When I draw the line that goes through those points, I've completed the problem and I have graphed the line. Please make sure you extend the line through both edges of that graph, and also make sure that you include an arrow showing that even though we are stopping drawing it, it does continue on in each direction. Apply the same sort of thinking to problem number 18, looking for that y-intercept. That's going to be at a positive 5 this time. So I'm placing that point right there on the y-axis at 5. Then I'm using my slope, which I can see is not just 8/3, it's a negative 8/3. Okay, that's our slope. That is our rise over our run. You just need to decide, do you want the negative to go in the top, or do you want the negative to go in the bottom? Is it going to be part of the rise, or is it going to be part of the run? And I want you to know it doesn't matter where it goes. You just need to put it in one of those places, not both. So starting at that y-intercept, I'm going to go ahead and use this one first, where I'm going -8, meaning a rise of negative that goes down, 8, and a run of 3, so 1, 2, 3 in the positive direction. All right? I would do the other version, but it would go off of the grid. So going to connect those 2 points that go through that y-intercept of 5. I'm having a hard time with this. That's going to be good enough. And that other point that I found using my slope. And that's it. Again, this is just a review. This is nothing new for you. One last thing that I really want you to pay attention to. On a problem like this, number 22, when you see this number, this is still your slope. It is 3, but we want to be able to write it as a rise over a run, which means I need to write it as a fraction. So I'm going to write 3 as a fraction 3 over 1. Because 3 divided by 1 is still 3. I haven't changed what it actually means. I've only written it so I can easily identify that rise and that run. That's it for today. Whatever you do not finish in class becomes homework. So please be diligent in getting it all the way done in class so that you don't have to have homework tonight over the weekend. That's it. Have a great day, and we'll see you next week.